Hi guys, I hope you're good since last video. This video is a dive in with me while I'm searching for a similarity search model. I think that I have found a good one. So we are going to experiment it easily and see how it goes. So relax max and enjoy. As always, please like and subscribe and let's get started. HuggingFace. So here on the side, for example, I was looking here for image to 3D. You can use here the search bar, or on the left side you can use the filters to find what you really need. So here we are going to look for an embedding model. So you see you have different kind of models here. They are, for example, here sentence similarity. And I'm gonna see which one we're gonna use. This one is from Alibaba. GTE-modernBert-base is ranked at the top. This one is a static embedding Japanese, but we're not going to use this, just to show you that there are some interesting also other models which are ranking at the top. So there's a lot of research around the Japanese, a lot of engineers, and here we're going to use this one, I believe. So let's test this GTE-modernBert-base. Here we get some examples in how we can use it, and we're gonna stay in this kind of code snippets. That's what I'm gonna try to reproduce. Okay, so you just go over it, look at the different informations. Here, this is a common way to use it. Also here on the right side, use this model. Sometimes you can use it directly on HuggingFace, or you can also get here a small starter code snippet, so you know what you need to install and how to load the model. So it's going to be downloaded automatically when running the code into your local environment. There's another way also that I've shown you in previous videos. You can download the model directly from here, from the files and versions. Sentence transformer, that's what I believe I'm going to use. So I'm going to play with different sentences and see if the similarity matches what I'm expecting. So we are in a chill mood. We're just gonna go step by step, do this test and see how it goes. I'm gonna make a directory sentence. I'm gonna call it sentence similarity. Let's move in this folder. Let's clean the page. So what do you do after that? You always do this. You get your Python environment set. So we're going to set a virtual environment that we're going to call .env. Source.env being activate. I'm going to activate it. I call it .env because sometimes I'm pushing my repository to GitHub, all my files, so that if I forget to ignore the virtual environment, it will be ignored automatically because it's a .env file. I think GitHub has implemented that. After here, I have created a file, app.py. That's where we're going to put the code in. to start with and to test. A requirement file. You can use pip, or you can just put the version in the requirement file and run it. Pip install our requirements.txt. We're gonna install this package, transformers 4.48.0, and here I'm just gonna put the code snippet that I got from HuggingFace, and we're gonna use it to run our tests. We're gonna just change those sentences. So first you need to get it running as quick as possible in your local environment, and after that you can start tweaking it, playing with it, implementing it, adding it to your code base, and so on. So here we're just going to create some sentences in this list input text. What is a manga kissa? Is Hachiko story real? Did he have a piece of paper and a pen? Next to Shibuya GR station. Okay, that's our second question. You might get the answer, as I have used that in some previous videos. I like udon from Kyushu. Udon, the big fat pasta, like noodles from Kyushu. Don't know if there's 2U or not. And here, let's put another sentence here. What is the best manga kissa? So I'm trying to get at least one sentence similar to another. This one is or where is the best manga kissa? While the first sentence is what is a manga kissa? So here we can expect those two sentences to have very close similarities. I'm going to try to run it, Python 3up.py, then module sentence transformers. So we need to install it. As I said, I'm going to use sentence transformers. So let's install it, because we didn't put it in the requirement file. We just didn't install the right. Let's do it now. Pip install sentence transformers. We wait a bit. It's gonna be quick to install. Or maybe not, because I see some CUDAs. So I might fast forward this part. So it is installed now. Let's try to run it again. Let's see what's the outcome. We got this cost function using those probabilities in order to see which one is the closest. So first here we need to download the model, so it's going to do it automatically. That means that our installation is going the right direction. After that we'll be able to run it. So when this download is done, we're going to have a little break, and after we're going to go into the testing phase. So always make sure that everything is all set and you're ready to run. After you can relax and start playing with the code. It's not a very heavy model. See here, 298 megabytes. That was the biggest file. And here we got it running straight away after. And the expected sentence has 89.03%, while the other ones are around 50%. Please like and subscribe during the break. And now let's go back to the code base. And let's play with the sentences. So the function is from a sentence transformer. The utilities is called the cos_sim, and that's the one which is going to be comparing. So in the similarities variable, that's the one that we print at the end. We are checking the embedding on the first embedding, the first index, 0. And after the second one is the other embedding, so the other sentences from 1 to the end. So here we got 4 sentences. Now we're gonna add the 5th one. What is a manga kisa? Coffee. And we expect the 2 last sentences to be closer to the first one. So let's see. Here in the result we're gonna have in the tensor 4. Yes, so as you see they're very close. 89.66%, here 89.03%. So this is promising, it's very good. So it's compared to the first sentence which says what is a manga kisa. Where is the manga kisa? I'm trying to get it closer, just to see if it's going to be incrementing this percentage, and yes, we're at 92.94% now of similarity. So this model can be used as a solid model for similarity comparison between sentences when you're doing your retrievals. And you can run it directly on text. It's going to do the job of embedding and comparing. So here, let's pick 1, 2, so 0, 1, 2, 3. We're going to pick the sentence called 0, 1, 2. I like udon from Kyushu. So that's the one that you have picked. Here, and I'm going to do another one for the other part. So here the sentence is going to be checked against the 2 first sentences, and here in the second variable is going to be checked against the 2 last sentences because it's in the middle. Just going to do it like that. Very easy to understand. Okay, so 2 to the end, and the other one, the beginning to, 3 to the end. And here we're going to be printing that similarity is 2. And here we're going to check. It shouldn't be similar because it's the sentence which is very different from the other ones. Let's see what is going to be giving us. Yes, so it's just like 53.84%, 58.30%. We're all around 53 to 58%. So we don't get this similarity being, I don't know, it has to be above 80. It depends on your requirements, because you can also decide that it has to be above 95%. I love udon from Kyushu. So I like udon from Kyushu, which is the index number 2. And the last sentence here is I love udon from Kyushu. So we expect in the second one to have 3 variables and the third one to be very close to it. So to be very significantly close to it, 93.87%. That's what we were expecting to see, and that's what we got. So understand why this model is ranked on the top of those similarity comparisons, some similarity models. So the embedding shape, we don't need it. I just comment it out. So which sentence are we going to compare? Let's compare the very long sentence at index number 1. So the indexes start from 0. So the what is a manga kisa? It's index 0. The next sentence, index 1, and so on to the end. So here we have 0, 1, 2, 3, 4, 5 for the index. And I'm going to be comparing this long sentence. We're going to add a new sentence, which is going to be similar to that one. It is the story of someone waiting at, I'm going to use some same words. So we expect this sentence to be the closest in similarity and to be also significantly similar. It is the story of someone waiting at GR station next to Hachiko. So we have those keywords with a pen and paper. It's okay. So we get that third keyword, so it should be enough to get it close. Now we're confident with that model. So what do we get? Yes, you see the last sentence, 84.52% similarity. So if you were searching for that, you would find it, you wouldn't miss it. But it's always good when you're getting your embedding to get at least 2 or 3 best results. But overall, it's a pretty good embedding similarity model. Similarity search, retrieval. Okay, so that's how I search, because I want to improve some of my different workflows, not use a database, for example, directly search from a text file. So when I'm done, what I do usually, I just get all the requirements in a requirement file using this command pip freeze, and you push all that into the requirement file. So here are all the dependencies that have been installed. Or you can also install pip-chill. Let's install it so that you can see the whole process. And after that, you use pip-chill and you push that in a requirement file. Here I'm just going to call it chill requirements. That's how I used to call it. And after, you're going to see here that it's going to be more compressed, giving you just the upper level of the installation, while the dependencies are going to be installed automatically. So those are the packages that you need and the different versions. Okay. Backport, metadata, Jaco. Pip-chill is because I've installed it. Platform deals, sentence transformer, and Tomly. And after that, you can push it to GitHub. I'll invite you to get the habit to go through HuggingFace and look at what you're interested in, using their filters, and see what you can run locally and play with it a bit. Maybe some great ideas are going to emerge from your explorations of HuggingFace. Then use the comment section to share it with us, as a good chunk of the viewers of this channel are ranging from age 35 to 50 years old. I'm sure that you can help us progress with your amazing experience. Okay, let's stop here. Hope that you liked this video. Please like and subscribe, and see you next time.